Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 030. This video's purpose is to teach students how to write ratios. So I'm going to do some examples that are similar to the examples you have in your homework problems. So first off, what is a ratio? A ratio is really just a way to compare two numbers. A ratio can be written in three different ways. One way is to actually use the word to, such as this example here, 16 to 24. So if one quantity was 16 and the other was 24, we can use the word to compare those. Another way is to use a colon. So a colon is another way to write a ratio. So this would also read 16 to 24. And then using a fraction bar is also another way to write a ratio. This would also read 16 to 24. So you can think about the fraction bar as representing the word to. One thing to keep in mind is that when you're writing a ratio, the order is important. So 16 to 24 would be written with 16 as the numerator and 24 as the denominator. If, for example, we had 24 to 16, and that was our ratio. Those are the two quantities that we're comparing. If we wanted to write that in fractional form, 24 would actually be the numerator and 16 would actually be the denominator. If we wrote it in the colon form, it would look like this. So keep in mind that order matters when we're talking about ratios. Alright, so the first problem says write each ratio as a ratio of whole numbers using fractional notations. Well, we kind of already have this first one, 16 to 24, in fractional notation. 16 over 24. But what we need to do next is to simplify that. So if we want to look at a factor, the greatest common factor that both of these numbers share, that would be 8. So if I divided the top by 8 and the bottom by 8, we would get 2/3. Okay. So we want to always write these ratios essentially as a simplified fraction. Okay. Now, calculators will do a lot of this simplification as well. You could either use a scientific calculator or you could use a graphing calculator, whichever one works. I'll show you how to do both here. This is a scientific calculator. So I don't know if you guys can see this. There's a bit of a glare. That's even worse. Zoom in here. Okay. There we go. So if I type in 16 and then this button here that's got the A, B, C, and the BC's in a fraction bar, that's your fraction button. So that little mark is essentially your fraction bar. So 16 out of 24, and then if you hit equals, it will essentially reduce that to 2/3. So this button right here, the A, B, C, that's your fraction button, and then when you hit enter, the calculator should simplify that for you. If you have a graphing calculator, and you have the update for your graphing calculator, you can hit alpha y equals, so the green button y equals, and then that actually has a fraction menu with it. So you could hit the first one, which is numerator over denominator, just a standard fraction, 16, go down to the bottom, hit 24, and then once again equals, and then that will reduce that as well to 2/3. Whoa, didn't mean to zoom in that far. So if you're not very good with fractions by hand, feel free to use a calculator. You can use a calculator for this course, either scientific or graphing calculator. Calculators should come with a instruction manual that'll show you how to essentially do those computations. And of course, if you have questions, let me know. Teaching math for a while, I get pretty good at working with all kinds of different calculators. All right. The next one, 7.7, or 7 7/10 to 10. Okay. So first thing to write this in fractional notation is to put the first number of the ratio in the numerator, the second number of the ratio in the denominator. So we get 7.7 over 10. Now this is not going to be a correct answer because we actually are putting a decimal in a fraction, and that's typically not standard procedure. So what we want to do is basically try to multiply the numerator and the denominator by the same number so we get whole numbers and we don't have any decimals. So I can multiply the top number by 10, and that'll move the decimal place to the right one time. Okay. If there was 2 decimal places up here, I'd multiply by 100. Right? That'd move the decimal to the right 2 places. So you can use your multiplication rules of powers of 10 to help you here. So if I multiply the top by 10, that gives me 77. And of course, I got to do the same thing to the bottom to keep everything balanced. And so I get 77 over 100, or 77 to 100 if we think about it as a ratio. And then of course if I could simplify that, I'd want to do that. That is not a fraction that can be simplified, so we keep it as it is. So if you have decimals in there, you want to multiply by powers of 10 to essentially move that decimal however many times you need to. Alright, and here's another example. We've got mixed numbers here, 7 3/5 hours to 1 9/10 hours. So we're going to start by writing this as a fraction, and what's going to end up happening is we end up getting a complex fraction. So I have the first number of my ratio, so what's before the 2 as the numerator, what's after the 2 as my denominator. And that looks really messy. Okay. Keep in mind that this fraction bar is another way to write division. So I can rewrite this as 7 3/5 divided by 1 9/10. And then using my rules of dividing fractions, I can continue to simplify this. So I'm going to write these mixed numbers as improper fractions. So to do that, remember we multiply the denominator times the whole number and then add the numerator to get the new numerator of our improper fraction. So 5 times 7 is 35, plus 3 is 38, and then I keep that denominator the same. Divided by 10 times 1 is 10, plus 9 is 19 over 10. Okay, so I'll just essentially rewrite the mixed numbers as improper fractions. Then I want to do my division with fractions here. So dividing is the same as multiplying by the reciprocal. So copy, write the first fraction exactly the same, change the division to multiplication, and then flip the second fraction. So multiplying by its reciprocal. And then I want to multiply there, although we do have some common factors. Both of these numbers that are on top and bottom share a common factor of 5, so I'm going to divide each of those by 5. These numbers here share a common factor of 19, so I'm going to divide each of those by 19. And then that makes the multiplication a lot simpler, and I'll also have this reduced already. So 2 times 2 on top would be 4. 1 times 1 on the bottom would be 1. So 4 to 1 would be the simplified fraction. Okay. So that's how we can write ratios in a simplified fractional notation. All right, let's look at some other problems here. This is a geometric problem. Okay, so we've got a triangle, a right triangle. We've got the side lengths of each of those triangles. Okay, so the first question says find the ratio of the length of the shortest side to the length of the longest side. All right, so here's a ratio essentially written out in word form. This is going to be the numerator of the ratio. Notice we have the word 2 here, so that's going to be the fraction bar. And then the denominator of the ratio. So the length of the shortest side of this triangle is 6, to the length of the longest side, which is going to be the hypotenuse, which is 10. So I get 6 over 10 as the ratio in fraction form. And then, of course, we want to simplify that. So we divide the top and bottom in this case by 2. So divide by 2, divide by 2, and we end up getting 3 over 5, or 3/5. So 3 to 5 would be the length of, or the ratio of the length of the shortest side to the longest side. So for every 3 meters of length on this side of the triangle, there's going to be 5 meters of length for the longest side of the triangle. Okay. The second question says find the ratio of the length of the longest side to its perimeter. Once again, the ratio is written out in word form. Here's the numerator. The word 2 is the fraction bar. What's after 2 is the denominator. So the length of the longest side we already discovered was 10. So that's the numerator. And we're comparing that to the perimeter. Okay. So the perimeter is going to be adding up all of the sides together. So 6 plus 8 is 14. Plus 10 gives me 24. So the perimeter is all of the sides combined, added up. That's 24. So that's our ratio. We want to simplify that. So we can divide each of these, once again, by 2. That's the common factor. So when we do that, we get 5 over 12. So 5 to 12. All right. So you can interpret this as as the longest side of the triangle increases 5 meters, then the perimeter would increase 12 meters. That's what you're comparing in the geometric sense. All right. Okay. So more problems with writing ratios. In this case, we're writing rates, and a rate is a specific kind of ratio dealing with a quantity. Yeah, the rate can be any type of quantity. So in this case, we are comparing money in weeks right? In this case, we're comparing miles and gallons. So a rate and a ratio are basically the same thing. You can think of that in similar contexts. You're comparing two different quantities. In these particular cases, they actually give us the units. So that's what makes it different from the other problems. In the other problems, we were essentially just dealing with numbers and fractions, and we didn't really specify any units to those. In this case, we actually do have units here for these numbers. So they're a little bit more applicable. So alright, so let's start out with the first $1,680 for 8 weeks. So we can write that as a ratio. So we've got money per week. So we can also think about this fraction bar as having the notation of the word per. Alright. So we want to simplify that. So let's see if both of those numbers are divisible by 8. And they are. So I can divide the top number by 8 and get 210. And divide the bottom number by 8 and get 1. So in the simplified rate, we get $210 for 1 week. So that makes it, a lot easier when we're comparing these numbers. When people are generally talking about salary, it's how much we get paid each week or how much we get paid each month. So it's usually per 1 unit of time. In this case, it makes sense to know that you're going to get paid $210 for every week. That's a lot more helpful than saying, hey, you're going to get paid this much for 8 weeks. This makes it easier to plan. So once again, we want to write that rate as a simplified fraction. All right, here's another one with miles per gallon. Right. So if you've ever bought a vehicle, you've probably researched miles per gallon on your vehicle. So 236 miles per 12 gallons. Okay. So we would want to reduce that fraction. Right. So let's see if each of these numbers are divisible by 12. So no. Let's see if 236 is divisible by a factor of 12, such as, say, 6. Okay, it's not divisible by 6. Is it divisible by 4? Yes. So let's start there. So I divided both by 4. So I'm just trying to come up with a common factor. So 236 divided by 4 is 59. 12 divided by 4 is 3. This is gallons on the bottom. So that tells me that I can get 59 miles in 3 gallons. All right, so can we continue to reduce that any? We can't reduce that any without getting into decimals. All right, so that reduces it and breaks it down a little bit better for us. If we wanted to make it into a unit rate, which is per 1 gallon, we would eventually get a decimal, and this is how you would typically see this if you were doing research on a vehicle. 59 divided by 3 is 19.67 miles per 1 gallon. And that's how that's typically read, as a unit rate. So these are rates. This is a unit rate because we're comparing that per 1 unit. And that's typically how you see miles per gallon, or MPGs, when you're doing research on vehicles. All right. So speaking of unit rates, that's our next group of problems here. So write each as a unit rate. So like I said, the difference between a rate and a unit rate is comparing the quantity per 1 unit. So Instead of knowing how many feet we have every 8 seconds, if I want the unit rate, I want to know how many feet we have in 1 second. So to do that, write the ratio, so 3,200 feet per every 8 seconds, and then just divide. So if I divide those two numbers, alright, I get 400, and that divided evenly. So essentially that means we have 400 feet per second. So that could describe, how fast something's moving. Alright. So write the second one as a unit rate, 78 bushels of fruit from 12 trees. So 78 bushels for 12 trees. So notice we're writing our ratio in order of the numbers we're given, and then we can divide those once again to find the unit rate. So 78 divided by 12 is 6.5. So 6.5 bushels per tree. So 6.5 bushels per one tree. And so in most cases, having the unit rate is a much easier way to compare and a much more useful ratio. And we see that quite often. Whether it's MPGs, right, miles per gallon, or when you're driving to school, and you're looking at your speedometer, you're looking at a unit rate, miles per 1 hour, right? So how many miles can you go in 1 hour? So we use unit rates pretty frequently. Alright. And then last but not least is unit price. And unit price has essentially the same meaning as a unit rate, but we're using it in context of money, right? So how much are you paying for 1 unit of whatever you're buying, right? And to come up with the unit price, you are taking the price and dividing it by the number of units. So very similar to what we just did with the unit rate. Okay. So in this particular problem, it says approximate each unit price to decide which is the better buy for a bag of nacho chips. So 11 ounces for $2.32, or 16 ounces for $3.59. So you may have done this type of math while you were shopping. A lot of times when you go to like Sam's Club or the big box stores, if you buy in bulk, you get a better deal. So that's similar type of scenario. So let's find the unit price of each, and then we can decide which one of these is the better deal, right? So let's take the first one to find the unit price here. We're going to take $2.32 and divide it by the number of units, which in this case is 11 ounces. So if we divide those, we get 0.2109. And of course, since we're talking about money here, we want to round to the hundredths place, which is the second decimal, right? So I look at the digit to the right, that's a 0, so that's less than 5, so that means this is going to stay a 1. So we say we're going to pay essentially 21 cents per ounce of nacho chips if we buy the 11-ounce bag. If we buy the 16-ounce bag, it's $3.59 for 16 ounces. So we're going to divide as well. So $3.59 divided by 16. Once again, we're going to round to the hundredth place, so the second decimal, so that's a 4, which is less than 5, so that 2 is going to stay a 2. We're going to keep it the same. So we're paying 22 cents per ounce if we buy this 16 ounces. So it's actually a better deal in this case to buy the 11 ounces of nacho chips. It's actually a better deal. Okay. So obviously that's helpful for cost savings purposes. If you're eating a regular amount of nacho chips, that's probably not a big deal, but maybe if you're a school or a hotel or somewhere where you're feeding a lot of people, so you're buying a lot of nacho chips, that 1 cent savings might actually add up to be a considerable amount. All right. Well, I hope this helps. If you have any further questions, feel free to email or stop by the office. Have a great day.